In grade 12, we are going to learn on annuities. This is one of the definitions that I came across in one of the textbooks. A number of equal payments made at regular intervals for a certain period of time and is subject to a rate of interest. So here my key words are that equal payments. So this is my keywords: equal payments, right? Regular intervals. Of course, there is a certain time and there will be period of interest. There will be a rate of interest. So here, in short, it means annuity means regular payments, right? Regular payments. I mean regular and equal payments, right? At regular intervals. At regular intervals. What is it mean? What does you understand? What is annuity in a real life application? Is nothing but the repayments that we make when we buy a loan, when we get a loan for getting a house or building a house, or when we buy a car. We have to pay a regular amount of installments every month. We have to pay. Those installments are in mathematics, we call them as annuity. It's nothing but your installments that we pay to the bank or to any financial institution when we buy something on credit. Remember, we can also invest a certain amount of money every month also and get a huge amount in future. So we have two kinds of textbooks. Your CAPS document says on two major kinds of annuity, which is called future value annuity and present value annuity. Future value annuity and present value annuity. These are the two annuities that we are learning. In fact, both of them are related to one another. Only thing, we are distinguishing them by means of formula, but they are the same thing. But in actually, there are two kinds of annuity. One that starts at the beginning of the period, and one starts at the end of the period. We are learning annuity at end period. We are learning annuity at end period. That means I am making my installments or making my payments at the end period. That is what we are learning, right? Most of the formula that we have seen in the information sheet is also annuity at end period. I'm going to explain the first annuity, future value annuity, by means of an example. At the end of 5 years, each year for 5 years, Kubo makes a deposit of 1,000 rands in an account. The rate of interest is 11% per annum compounded annually. Determine the value of the investment at the end of 5 years. So what is happening now here is Kubo is making an investment, right, for 5 years. At the end of each year, for 5 years. Therefore, let me draw a timeline here. So this is with T0 and this is my T5 because this is where I am. My last investment is. It is at the end of year 1, at the end of year 2, at the end of year 3, at the end of year 4. I am making an investment. So I make an investment here. I am not making at the end of each year, right? So I told you, what is it? We are going to end the period annuity. Therefore, my period here is ES, right? Because it's compounded annually. My period here is at the end of the period. So I'm making an investment at the end of the period. And how many investments I'm making? At the end of each year for 5 years. So at each of these periods, I'm making an investment of 1,000 rands. So at each year, at the end of the year, at the end of first year, I make an investment. At the end of second year, I make an investment. At the end of third year, I make an investment. At the end of fourth year, make an investment at the end of 5th year, and make an last investment. Now the question is how much money I'm getting after 5 years, right? So I start from here. This today's date. After 1 year, I deposit 1,000 rands. Second year, 10,000, 1,000 rands. Third year, 1,000 rands. Fourth year, 1,000. And fifth year, 1,000. This is what I'm going investment making. Therefore, how much? Let's look at the term, number of years. So this one, T1, right? T1. Listen very carefully. T1, how many years it takes? It takes up to here, right? It is 4 years, right? Right, as from here it is 5 years, right? Is 5 years, right? But from first year, end of first year to the end of 5 years, it is 4, right? Listen very carefully. So it is, if you look at the sigma, right? N is equal to 1 to 5, right? N is equal to 1 to 4 actually it is, right? N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4. Right, so it is sigma is equal to n is equal to 1 to 4. Okay, so I have 4 years here. Forget about the sigma now. It's 4 years. Now then, this one is for term 2, right? For A and T2 is going to be 3 years, and this investment is for 2 years, and this one is for 1 year, right? And there is no investment. I'm making 5 investments, 1, 2, 3, 4. Therefore, this is for 4 years. This T2 is for 3 years, T3 is for 2 years, T4 is for 1 year, and T5 there is no investment, 0, right? Therefore, what are my interest? What is my interest compound rate, right? So it is 1,000 rands, right? 1,000 rands. This is going to fetch me for 4 years. This is my compound interest for 4 years. This is the compound interest for 3 years. And this is the compound interest for 2 years. And this is the compound interest for 1 year, right? And this is the last one, is doesn't have any interest, right? So these are my five compound interest, right? Of those, the last one doesn't have a compound interest. So these are the 5 times I'm adding it, because it's investments for 5 years, right? So number of terms will remain 5. Number of terms will remain at 5. Now, if you look at this, do you see any kind of a series here? Just make a guess. What kind of a series is this? If you observe very carefully here, and that this series here is nothing but a geometric series. A geometric series, right? I'm adding them. So we apply, so I have to add them. So I apply the sum of first n terms of a geometric sequence. So what is the sum of the geometric sequence here? So I take this as the first term. I take this one as the first term, right? So I'm rearranging it. That is the last one. I can rearrange it. So that will give me 1001 plus I to the power of 1 plus 1000 to 1 plus I to the power of 2 plus 1001 plus I to the power of 3 plus 1000 times 1 plus I to the power of 4. So what is my sum of the sequence of geometric sequence? This is geometric sequence. So Sn, right? So it's actually S phi here, right? S phi, because the time is phi. So my first term times Rn minus 1 divided by R minus 1. That is, my R is here, my R, this is my R. My R is 1 plus I is my R. Okay? You can see that. So my first term is 1000 rands. My first term, this is my first term, this is my first term here. First term is my 1000. That is nothing but the equal installment amount. A times, and this is what is my R. R is 1 plus I to the power of n minus 1 divided by 1 plus I minus 1. So that is my formula here. 1000 times 1 plus I to the power of n minus 1 divided by I. So this is the formula for the future value of annuity. Future value of annuity. That is my first term, I assumed to be x. We call them as x here. Our textbooks, our CAPS document prefer to use the word x for the equal installments that we make. So that is my formula here. 1 plus I to the power of n minus 1 divided by I. So this is the future value formula of annuity. Please refer to your information sheet. What is the formula for the annuity? This formula is there. Future, they have written only F, but I have written future value FVA as annuity. What I want to emphasize here is that the future value, the amount that we write here, the amount that we write, right, in compound interest or simple interest, whatever it is, this is my future value. So amount, I am replacing the word amount with future value. Something that we get an amount in future is called future value, FV, right? I prefer to write FV. And the investment, the principal, I call them as PV, the present value. Present value. What is the value present today? The investment that I make. Right? So this is my future value and this is my present value in the case of the compounding formula. So I am not going to learn is now, I'm not going to term them as amount, but I am going to call them as a future value. The amount, something that I get in future, is called future value. The investment that I make today is called the principal value. The amount that I received as a loan is a principal value. Right? So understand the difference between the present value and the future value. If there's a transaction of huge amount, the bulk amount that happens today is called the present value. The bulk amount that I'm going to get in the future is called the future value. And X here denotes the equal monthly installments or equal installments, or called the annuity. In this case, it is annual. Sometimes it will be monthly in practical cases. So this is my equal installments is called X. Of course, I is my interest rate and I is the interest rate, and N is a period, right? So now let's try to calculate the future value, right? So I have my equal installments as 1000 rands, and 1 plus I. What is my I is 11%, right? So it is 11%. And what is my period? Period is my 5 years minus 1 divided by 11%. So what I do here is I apply the formula. First is I apply this fraction symbol here, and on the numerator is 1000 times. I open the brackets. Then again there's another bracket here. So the two brackets that I'll open, right? And then 1 plus 11%. 11. Either you can again put a fraction 11 over 100, or you put 11%. Then come outside the bracket for the inner bracket, minus 1 divided by again it is 11%. So don't try to calculate 1 plus 11% separately and then do it again. No, we'll do everything in one shot. So I forgot to put here to the power of 5. So it's to the power of 5 minus 1. So we should be very careful that minus 1 should come outside the power. So there are two brackets that I'll open. The inner one is for 1 plus I in rate of interest. So that is 1. Then I put the value in the calculator and I get the value as 622,7. So I got the value as 6227,80. So that is my future value, 6227,80. What I want to emphasize is that Even if I calculate these values separately, I will still get 62,780. Right? That means if I do the calculations, 1000, right? 1 plus I to the power of 4, I get, I'm using calculator, I have used calculator, 1518,07. Then it is for 1000 power of 3 for 3 years. I will get 1367,63. Then again for 2 years, 1 plus I to the power of 2. Yeah, I stands for 11 percentage. 1232,10, 1001 plus I to the power of 1, and that will give me 1100. And of course the last one is only 1000. So if I add them, I'll still get so 1 2 3 4 5. 5, so I should be 5 here, 5 plus 3 8, 8 plus 2 10 11, so this becomes 6, and is 11 here. 6 plus 1 7, 7 plus 3 10. This one carry forward, so 1 plus 1 will give me 2. So this is how much here? 6 plus 1 7, 7 plus 3 10, so it's 1100 here actually. And that is this is 1100, not 11001. Yeah, so that will again give me 11 here. So 8 plus 7 15, 15 plus 2 7, 17. So this is 1 plus 2 7, and then 6 plus 1 7, 7 plus 3 10. So this will give me 6227,80. So that is either way. So instead of calculating this, I'm using the formula which we call them as a future value formula. Is nothing but our formula, that is our geometric series. To understand annuity is to understand that it is a geometric pattern. So that is a key here.